so if everyone's ready, we can start. Good. That's fine. Right, so, how did you find homework? Was it easy to navigate the flow and everything? I hope it was easy. Okay, so yeah, what I wanted to mention about homework is that even though the column in Jira is called code review, the Confluence tickets also should be moved there. This is for me to understand when I go to your board that if you have something code review that I need to review it, and then when I write a comment in the Jira ticket or approve a pull request, then you can move it to that. So this is for communicate. Okay, that's one thing. I also wanted to confirm that everyone's okay with moving the lesson from 21st to 20th to the Tuesday. And then you'll have a couple of like consecutive days to catch up on your homework and so on, because there's legal there. And so there will be several days for you to catch up with homework. Okay, next thing, Valdis asked a good question about branches. Since we are like doing a task, then we are finishing it and not returning to it, it is safe to delete those branches. So once you merge your ticket, you can delete the branch. There is like when you merge it in GitHub, you can see that do you want to delete it, and you can press this button, and it's fine to do so. This way you won't have like a backlog of a lot of stale branches that will never have any more development in there. And you can always, if for whatever reason in the future you need to restore this branch, GitHub also allows us to do this. So it's pretty much safe. Okay, great. Today we will be exploring Dart language. We will be doing a lot of hands-on exercises. So you will need to follow along. But one more thing that I wanted to show you regarding the previous lesson and what I've seen from homework is adding files to gitignore. So example, here's our code. This is the very basic learning Dart, the same app as we did when you created the Dart app, the Dart create learning Dart one. And the thing is, if we commit this all to Git, this is okay. But our IDEs, for example, Android Studio, generates this folder called .idea. It's invisible, and it just has some like kind of configuration files and so on that are only relevant for your computer. And the same goes for VS Code. So a folder like VS Code can be generated and so on, many other IDEs that you use. And in general, in the future, you may create files that you want to save only locally, but don't want to commit to Git. For example, sometimes it can be code-generated files or files that contain secure information that should not be available remotely. And in order to not push those files to Git and to make it automatic, not like every time you need to think about it, you can add files to this special file called gitignore. And basically, this file describes all kind of folders, patterns, and so on of things that should not be published to Git. So in our case, this should be also idea. You can either write it like this ourselves, or if, for example, you don't want to write it yourself, or the path is long or something like that, you can right-click on any folder or any file that you don't want to push to Git, press button Git, and then you should have this add to gitignore. And we select the first one. And it automatically adds this for you. Okay, and then you can see here in yellow that this folder is like yellow color. It means that it is in gitignore. So IDE also helps you to understand what is actually pushed and what is not. And it's also safe to delete this folder in general because it gets regenerated every time you do something in Android Studio. So it's safe to delete it. It's safe to delete anything that is like with this dot, which is generated for you. Okay, so I'll just quickly commit this. Okay, great. Now, another thing that I wanted to discuss regarding homework is that I assume that most of you, at least that's what I would do, would check the version installed like this by calling Flutter Doctor. And I can see that it says 3.10.1, blah, blah, blah. But a thing that interests me is that in here it says channel stable. So what is important to know about Dart and Flutter? They are both open source, so you can find them on GitHub. You can see all of the source code, like there's no secrets from you. And this means that all of the active development, all of the new features that are not yet ready for production and so on are also available in this open source. And in order to distinct between them and for developers that use Flutter in production to always have stable builds, they have different channels. Channels in this case is the same as different Git branches. So they have stable, they have beta, they have master, and maybe alpha, I'm not sure, but those three definitely they have. Master is the most unstable branch. It can break and so on. So basically all of the development in Flutter and Dart happens in their master branches. So if you feel risky or you want to try out any super like new things that they have just committed, you can always switch to master and run Flutter from there. So yeah, but for production, for real apps, we always stay on the stable channel. Same for Dart. Dart goes is with Flutter in our case because it's baked, not baked, but it's provided in the Flutter SDK. But in general, you don't have to have Flutter to develop with Dart. There are developers that don't use Flutter but use Dart, and this goes the same for Dart. They also have stable, master, beta, and maybe alpha channel. I'm not sure. Okay, great. So now let's stop this from running and return here. So Dart language. So the goal for today is to understand how to create and run a Dart application. We actually already know that because we did this on the previous lesson. And we need to learn some things about Dart, its syntax and the concept, including dynamic and strongly typed variables, variable modifiers, function, their return types, and their parameters, collections, conditional statements, loops, classes and objects, and nullability. And a couple of words about Dart language. It's object-oriented, class-based, garbage-collected language with C style, or how people like to call it, it's a language that you already know, because it has a lot of concepts that are present in other languages. And if you have experience with Kotlin, JavaScript, but mostly TypeScript, and or any other like, strongly typed language, probably you will know a lot of similar concepts. And also, because initially Dart was created long before Flutter, its idea was to work with the Chrome engine, I believe, and kind of substitute JavaScript. This didn't really work out. JavaScript is still here up to this day, but Dart can compile to JavaScript. This is how currently it works on the web, how Flutter works on the web. The actual Dart code that we write gets compiled to JavaScript and run on the web. In case of mobile applications, it does not get compiled to JavaScript, but it gets compiled straight to machine code. It also kind of makes it more secure than in case of Java, but we will talk about this maybe sometime later. But yes, Dart compiles into native machine code on different platforms, Windows, Mac, iOS, Android, and so on. And also some of the recent, like very recent developments that were announced just like on, I believe, Google I/O when Dart 3 was launched, is that it's working on, and I think it already works, it compiles to WebAssembly so that Flutter Web will be even faster in the future, but there's still some work to be done. So an important thing to know is that it's developed by Google, so it is really important to Google. And it also makes it convenient to be used for Flutter because Flutter is also currently developed by Google. Well, Flutter is an open source SDK, and there's a lot of open source contributors not related to Google in any way, but Google is like the biggest sponsor of Flutter, we could say it this way. And yes, Dart was created more than 10 years ago, actually. And a couple of important things that were introduced in Dart along the way is that before Dart 2.0, it didn't have any type system. We will talk about types soon, but in general, it was more similar to JavaScript, where anything could be everything, and you didn't have any strong types. So in Dart 2.0, type system was introduced, and now it's a safer language. We will also take a look at practical perspective what this means. but it didn't have any null safety. So I don't know. Do you know what null safety means or no? Okay, it's okay. We will be looking at this today. So we will return to this, but you will understand how this is a major feature. At some point in the past, this was the same major feature that Kotlin introduced as a successor to Java, because what they call it, I think it's called $1 million error, the null pointer exception, because Java is not a null safe language, and there have been so many null pointer exceptions that it costs like $1 million to the users of Java language. And most recently, Google I/O this May, a month ago, Dart 3.0 was introduced, and they have introduced a lot of new features that developers from other languages may or may not know. They're called, for example, patterns and records, and many more class modifiers. This is more advanced stuff, and it's also kind of controversial from my point of view what they have introduced, because up to this point, Dart has been somewhat of a simple language that is easy to work with, easy to not shoot yourself in the leg. But as more and more advanced features get added, it's much easier to make mistakes of which you don't even know. But we won't be talking about pattern and records at this point because it's not that relevant. All right, and with this, I have no more slides. So we are going to the IDE. Second, let me stop presenting like this. I'll present you just one window. Just a second. So you can, meanwhile, you can open your Learning Dart homework project in Android Studio. So it's your own original presenting out. Okay, and the first thing that I want you to do is in your lib folder, create two folders called class and home. Okay, and also for later, we can probably delete the bin folder because I will just be doing everything in the lib. But for now, let's see. So let's start with test. Oh, you can create not test task of factor name. Can you please create a file called task0, a Dart file? And this is where we will be writing our first code. Yes, in class folder. For me, it's demo, but for you, it will be class folder. So since you have all did your homework successfully, you probably already know that we have a main function, right? And a main function also, as in many other languages, is the entry point for a Dart program, for Dart and a Flutter program, as well as Java, Kotlin, and many, many others. So this is a way to tell compiler that the execution of the whole code of the whole program starts here. So it's an important kind of function. You can also have arguments here that you can pass. Yeah, okay, remember. Yes, it was list. Arguments that you can pass to the program, for example, file to open or anything like this, but for the sake of learning, we won't be needing this one. So it can be just an empty main function. Okay, and yeah. Dart is a strongly typed language, as we said. It can be a strongly typed language. And a strongly typed language means that we can create variables of specific types, and they will stay this type. For example, if I want a variable with a string value called name, call it Daria, there is no way for me to then make name, for example, a number 2 value. I can't do this because it is red. Like you can see, it's red. It won't compile and says that a value of type int can't be assigned to a variable of type string. So in Dart, you can do that and should do that. And this makes your code much safer because everywhere where you use name, you will always know that this is a string and there won't be any other unanticipated value like an integer or a double. The same way we can create, for example, int, I don't know, age, and we can't make it that there's no way for this. It will scream that it's not a type string, it's a type integer, right? Another in Dart, if you come from any other languages which has primitives, for example, in Java, well, there's no such thing in Dart. Everything is a class. So everything is a class. It makes it much simpler to comprehend. We will return to classes also soon. There's also doubles. Doubles is a special type of number that can have fractions. Thank you, GitHub Copilots. There's also a special value called Boolean, which can have only 2 values, true or false. Have you all used Booleans before? You know what it is. Okay, great. So then you know what is a Boolean. And the same way as operations with all Booleans everywhere, we can use the OR operator. So the Boolean works in IT will be true if either is developer is true or is designer is true. And can also use AND, which will be true if both is developer and is designer is true. Okay, and this variable will be called unicorn developer. And if you don't know, it's a term in IT which is used for developers that are also designers. So if you are a designer and a developer, you can be called unicorn developer. Okay, and now let's just print all of this to the console to see that it works. You can watch for now because I'll give you a couple of minutes to then do the same because there's another thing that I want to explain to you. So in Dart, in order to use variables in a string, for example, I want to say print my name is, and I don't want to type Daria. I want to show anything, everything, or anything that is in a variable called name. Then I need to use a $sign. And after $sign, I can enter any name of the variable. For example, name. Okay, and then I can do the same. I am, and then $sign, age, years old. Okay, and this way I can use variables. And I can comment the code by using either 2 slashes like this. This code won't be executed. Or I can also make a multi-line comment, for example, by opening a slash and a star, and also closing later on a star and a slash like this. This is code that won't be executed. Do you all know what comments is in code? Okay, that's cool. Okay, so if we then run this app, see, even Android Studio understands that main is an entry point, and it allows me to run just like that. And then here in the console, I can see that my name is Daria, blah, 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 blah. Okay, and the task for you is to do the same. What about yourself? So you need to create variables: name, age, how many years you are. You can change it to in university, in your profession, or anything. But basically, what you need to do is to use four kinds of variables: string, int, double, and a boolean, and then print out the results. Is that we use in Dart for method names, for variable names, and so on. Well, okay, for method names and for variable names, we use capital case. So it always starts like with a small letter, is developer with a small letter, and every consequent word starts with a capital letter. There's also snake case, for example, bool is developer, or I'm not sure how you call it, like capitalized camel case or what, but for example, this is not how we write in Dart. So not Dart. I mean, you can, it will compile and it will work, but the consensus and which code you will see the patterns is like this. Okay. All right. So up to this point, we have only described variables with specific types, right? So string, int, double, bool. But Dart is more complex than that, and also more smarter. And we can do, for example, without saying that it's explicitly string, to something like this. Var name. I'll just comment all of this code so that it's just removed. Var name. All that. Yeah. I haven't explicitly said that name will be a string, right? It just says that it's a variable. But if I try to do this, Dart will still scream at me that a value of type int can't be assigned to a variable of type string. And this functionality of Dart is called type inference. So you will hear this term probably also in the future, but type inference means that inference, I hope I'm saying it correctly in English. It means that Dart compiler looks the first time this variable is initialized, understands that this is a string, and records in its own memory, wherever, that this variable will always be a string. And then it won't allow you to do this. But another thing that var keyword allows to do is to change the name to something else. So this we can do. So it was Daria, but now it's Anna. And if we print this, just print the name. We will see that here in the terminal, we can see the word Anna, right? Just a second. But what if I don't want to allow to change my name? So like the name should be unchangeable only once when I declare it. It's the only time when I should allow my name to exist. So for that, we also have a special keyword. So var is a keyword in Dart. There's another keyword called final. And I can say, for example, final name 1 equals Daria. And if I try to say name 1 now equals Anna, it will squiggle in red and scream at me that the final variable name 1 can only be set once. Try making name 1 non-final. Non-final means I can make it either var, like we did at the top, or string. But if I say it's final, then it's final. There's no way for me to give it another value in the future. This is very useful. We will see later how this can be useful and safer, because this way you can always be sure that once you assign a value to this variable, it will never change, and you can always assume that it is what it is. But what if I want to make sure that the name one is final, but at the time of actually creating this variable, I still don't know what it is. Like once I give it a value, I want it to always say this value, but I don't know it exactly right now. There's another keyword for that. I can say that this will be a late final. And then I don't have to call it. I can then give it later, but only once, because if I try to do it once more, it will tell me the same thing. The late final local variable is already assigned. So that's another trick. There's more to this late keyword, but we might, or we will discuss this in the future. But for now, what you need to understand is that if you want to keep it final, but don't give it value at the time of initialization, you can use a late keyword. Okay, so let's just test print name one. Should be, we should see, okay, Anna one. We should see Anna and Anna one, right? Right, we see Anna and Anna one. All right, that's one thing. And last thing about immutability, this notion, like in case of final, is called immutability. So this variable is immutable. It means you can't mutate it. So you have given it a value and you can't mutate it. The variable, the var1, is mutable, means that you can give it other values and you can mutate it. It's okay if you don't remember all the terminology right now. We will just be talking and remembering it again and again. So you will get used to it. Okay, so there's one more option for us that we can do if we want to make sure that a variable is given at the time of creation, and it also stays like same throughout the whole lifetime. And we can use a keyword called const name 3. Say Anna. Okay, wait 3 if it should be 2. Let's say Anna 2. And this will work because we have given it a value at the time of declaration. Of course, we can't do this because it will scream at me saying constant variables can't be assigned a value. We also can't do this. It will scream at me that members can't be declared to be both const and late. No, const is always, it's known at compile time. So even before we run this program, the compiler already knows the value of constants. So for example, even though, let's say final is also final and it can't change. Okay, in here, yes, we can't do this, even though it's final and it's defined, because it will scream at me that const variables must be initialized with a constant value. So if I do something like this, const name const, for example, I can give it to the name 2, but I can't give it anything that is not constant. And just a value like this, it is constant, but when it's called in a variable which is not constant, it's not constant. You will also get used to it with time, and we will be working a lot with the const types of variables. But yeah, any questions about final and const so far? No? Okay. Then we will do a small classwork where I will copy this text to you. I will post it in Slack. So let's review it. First thing that you need to do is create a variable with the name day of the week and give it a value Friday. On the next line, change the value to Saturday. And finally, print out the value of this variable. Second, create a variable with the name last name and give it a value of your last name. Make sure that you can't change the value of this variable and print out the value of this variable. Third, create a variable with the name date and don't give it any value during initialization. On the next line, assign the value of today's date or any other date, and make sure that you can't change the value after assignment. Print out the value of the variable. And finally, create a constant variable with the name pi and give it a value of 314 and print it out. I will leave you the code. You can also, what was that about? Yes, you can create a new file, for example, task 2 or task 1, or whatever the previous one was called for you. Yeah, I encourage to have them in different files so that you can commit them all, and you will have all of those files when you have homework, because homework will be also reiterating all of those concepts. And I will also, of course, send you all of my examples too. So don't worry if something doesn't work out for you. You will have working examples. Any questions about that? Any confusions? Okay, great. Now I will create a new task. Don't ask why it's 13. That's a little system, but so up to this point, we have created variables that have a definite type. So they're either double, either string, int, and so on. But Dart is more flexible than that. And because those types, like specific types, were introduced only in Dart 2.0, initially, nothing had a strong type and everything was what's called dynamic. Okay, so basically this is also a new keyword, the same as var, final, and const. You watch it and you forget it after this, please. This is not safe, and I will show you why. So, okay, we have created a variable called name with a type dynamic, meaning that it can change, and the value is variable. But for example, I will also write a function called print name, string name, and I will just print name. Okay, and then I can call it here and run it and see what it prints. It prints data and everything is fine so far, right? So this makes sense. But what I can do now is also change the name to a value 32. It compiles, it works perfectly fine, because with the word dynamic, we said that this is a magic box, I can put anything to it. And if we run the app now, it also, no red lines, no anything. If you run it now, it will scream at me that I have an unhandled exception. Type int is not a subtype of type string. The thing is, why Dart allows this is that it might be a bit hard to comprehend right now, but it will come back to you in the future. Every object, like every type of object, string, int, any of the objects that you create, up at the very top of Dart, all extends dynamically. So it's perfectly fine when you pass like a parent class, in this case dynamic, and it compiles. But in runtime, like when we actually run this program, the type has changed. We pass it, but it anticipates a string and we get an exception, right? And this can happen in a real production application with more serious problems, and you won't see any errors compile time. Everything compiles, everything's good. But in runtime, you have errors, right? This is a problem. So if we even made it just var or just string, this wouldn't even compile. Like if I try to run task 13, it says that error. It won't even run. It's not running. It just tells me that error. A value of type int can be assigned to a variable of type string and tells me where. That's why strong types are important and make the code much safer. Okay, is this understandable? Okay, cool. Then we won't be doing a task for this, so you don't make a muscle memory of this type of pattern. So we will move on to the next one, to the nullability. Okay. Third task. So one thing that we have done up to this point is we have made sure that the value of the variable is always available. Title, for example, right? So I have created a new variable, call it university title, and give it a value of RTU. RTU. So weird to say it in English. So yeah, and if I run it, I'll just print the value in the console, and it works perfectly fine. But what if this variable is description of a real person, right? And there can be a case when they haven't studied in university or are not studying in university at this point or anything. So it's perfectly fine for university title to not exist because university for this person doesn't exist, right? So in order to do this, we can do a small little trick and say string with a question mark like this. So we have just added a question mark here. And this will mean to the compiler and to the whole program is that university title can either have a value of a string, for example, RTU, or no value at all. No value, just no value. And it works. See, there's no red lines, everything compiles. And this means that no value in programming is often called null. Null or nil or something like that. In Dart, it's null. So null value means there is no value. It's not that there's a default value. It's not an empty value. It just doesn't exist. There's none of such value. It just doesn't exist. Okay, and if we run it, we will see exactly null in the console. And what we can do with those nullable values, we can always check if there's a value present. I will give you a task for this, so don't worry. So we can do if university it screams at me because it's too smart, but for now, let's imagine that there's more codes to this. What I can do is I can check if university title does not equal, okay, no, this is stupid, GitHub Copilot, go away. I can check if university title is not null, print it. Else, print that this person is not a student. So if we run it, okay, I'll just remove this for now. If we run it, we will see that it prints not a student, right? Because the value is null. But if we give it a value, we can also make this more interesting. Studying at university title. So study in university. And then if we run it, we can see that studying at EDU. So this is a concept of null and non-null values. And to the Dart compiler, it is in order to make a value be able to be null, we have to explicitly tell it. And we do it by appending a question mark like this to the type. Okay, because if I do this and do this, it starts screaming at me. It says that the non-nullable local variable university title must be assigned before it can be used. This is what's called null safety. If I tell the computer that this will definitely be a string without a question mark, then I'm responsible for giving it a value because Dart compiler is promising to the compiled program that there will be a value of this. Okay, is this concept clear? Okay, cool. Then it was task 4. And just to have a muscle memory, do the same thing. Following this pattern, create variables of different types to describe your hobby, job, or anything else that you want. But it also should be nullable. Okay, cool. Awesome. With that, we're done with variables, and we will move on to functions. So we can create a new task file. Okay, so up to this point, we have only where's code? What is happening with my formatting? Oh, here you are. Okay. We have only worked with the main function. Everything we wrote was in the main function. But imagine if we have a big program with thousands of lines. We can't keep everything in one function, right? Because it will be completely unreadable. So, and also if you want to reuse code, for example, print numbers, print any values and so on, but this can be printed with different kind of values, we need to use functions, right? So let's first write a very simple function to explore the anatomy. Print hello world. Okay, and then we can call this function from the main function. And the function consists of a couple of things. First is the return type. So what is a return from this function when it gets called? In Dart, there's a special kind of types called void, meaning that this function executes something, but it doesn't return anything. There is no return value. It is void. Okay, then we have a function name, print hello world, followed by just braces, and we will return to them soon, and then followed by curly braces. And this is called the function body. And then here you describe everything that you want this function to do. Okay, and then we call this function from whenever we want. But okay, let's just run to make sure that it works. Okay, it has printed hello world. This is not interesting. Let's spice it up. For example, we will write a function void print full name. And I want to make sure that I can call. Please stop. That I can print names with all kind of names, not just one specific hard-coded data. I just want to pass any kind of name, and it will print it in the same format. For this, we have function parameters, and we describe function parameters inside those curly braces, which follow, not curly, just braces, which follow the function name. So, for example, we want string first name and string first name and string last name, right? Just two parameters passed in the braces and separated by a comma. And now I just want to print them. Print username is first name, last name. Okay, and then I go back to my main, and I want to call this function. And to do this, I need to pass parameters because now it will be screaming at me that two positional arguments expected by print full name with 0 found. So what we need to do is to pass parameters. And these parameters that we're using right now are called positional. So we need to pass them in the order they are created in the function. So string first name and string last name. I don't know why he's saying Kuznetsova, because I'm not Kuznetsova, so go away. And if I print it, if I run this program, I should see that it says username is Daria Blova, right? I can pass those variables as is, like this, without creating any extra variables, or I can create, for example, final name Alex, final last name Smith, and we will just put name, last name, and it prints username is Alex Smith. But what if we edit this function a little bit and say user first name is first name and last name? And to spice it up, we will pass the parameters in another order. We will pass last name and name. It's perfectly fine. 2 strings. It's anticipating 2 strings, right? What will happen now? Now it will say user first name is Smith and last name Alex, which is some stupid things because this is not correct, right? And this is why positional arguments, where we just pass them one by one, isn't always the best pattern. How can we avoid this and make sure that no matter in which order do we pass name and last name, they will be always correct? Because imagine a function print full details that has 10 arguments, all of them string. And you need to make sure that you pass all of them in the correct order every time. Otherwise, just mess up 2 strings and it already has incorrect data. This can be like bad for security, and it can also be bad for performance because it can like perform incorrectly. For that, in Dart, there's a notion called named parameters. So we will say void print full name 2. We will copy the same print. We will also copy these 2 same parameters. But now we need to do one more thing. We need to surround them by curly braces. Like this. Do you see the difference? So it's completely the same as the previous one, but the parameter names are surrounded by one more braces, and this time they're curly braces. Okay, and but it's still screaming at me, right? It's still screaming at me. It's red, and then if I put my cursor there, it says the parameter first name can't have a value of null because of its type, but the implicit default value is null. So what we're saying here is that, okay, there are 2 notions to explain here. First of all, the same goes for function parameters. If we specify that they are not null, there should always be a value. So in order to make sure that those values are passed, we can do this. We can give another keyword called required. We will see in a second why it's like that and what else you can do. But for now, if we use a word required, we already promised the compiler that whoever calls this function, print full name 2, they will pass parameters first name and last name. So if we do it now like this, and one more time in another way, for example, full name, let's say last name, and first name, just name. Right, so we can pass them in any order. And what is different from the previous function is that besides just passing them as positional, like 1, 2, we prefix them like this, with which exactly parameter we are passing which value. It can be confusing at first with syntax, but as I said, with practice, you will get used to it. For now, we need to understand the notion, and then you will get hands-on practice. So this way, let's see, this is line number 1, this is line number 2, and this is line number 3. And in here, we can say that see that the first name is Smith and last name Alex, the first error that we have, which is illogical. but the next two lines are the same. User first name is Alex and last name is Smith, even though we passed first name and last name in different order. So in case of named parameters, the order doesn't matter because we specify them by name. This is if we use required. Now let's recap. In here, in print full name, we have used positional arguments, positional required arguments. We don't need to specify required keyword in here explicitly because this is how Dart's syntax works, but they are called positional required arguments. On the next function, we have used named required arguments. So their position doesn't matter, their name matters, and they're also required. And the reason why the keyword is needed here, because parameters can also be named, but optional. So let's see how this works. Print full name 3. Copy the same text. We will copy the same parameters. And remember, returning to this one, it screams that parameter first name can have a value of null because of its type, but the implicit default value is null. There's two things we can do. We can make it null, like this, specifying that the string will be nullable. And if we now go back to our main and call this function, print full name 3, what we can do is just call it like this. The difference is that we don't pass any parameters in here. See, nothing, and it's compiled. And your guess, what will be printed on line 4 when we call this function? Yes, use it. Let's
use the text. Use it for savings, no?
Yes, yes. Okay, and let's check if you're correct. Okay, and user first name is null and last name null. Which is also probably not the best behavior, right? Because what does it mean that username is null? For a user who is not a programmer, null is like what? Well, what does that mean? So in order to avoid this, we can give default values and keep the type non-nullable. So I'll just copy this function right here again, change the name to 4. And instead of making them nullable, I remove the question marks. I can do one more thing, and that is give default value. So the syntax is like this. Oh, first name equals and unknown. This is more user-friendly, right? Because the users of the program who are not programmers know the word unknown. And if I call function 4 now without parameters, what will I see? Okay, and the full string?
What will the first name is null?
Okay, let's run and check it. And that is correct. User first name is null and last name unknown. Okay, but I mean, we want to pass names at some point, right? So what we can do is we can do this. We can do this. And we can also do this. And optional named parameters allow us to specify them in any order and specify all or none. So in this case, we will pass first name. In the second case, we will pass last name. And the final case, we will pass first name and last name. We can also just check, we can also do this way, passing last name and first name. And I'll just comment all of this for now so that it doesn't flood anything. And if we run it, we will see user first name is Daria and last name unknown. User first name is unknown and last name Orlova. First name is Daria, last name Orlova. First name blah blah blah. So it worked the same. Okay. Any questions about this right now? Because we will do a task now. Okay. One thing that I want to mention about general and practices, how I prefer to do it, is I always prefer named parameters, except very, very simple cases. By simple case, I mean if there's only one parameter needed to the function, it's okay to make it position as a single parameter. Second case, two parameters of different types. Also usually okay if I need to pass a string and an int or an int and a string. It's okay because a compiler won't let me pass them in the incorrect order. But in cases like print full name, even though there's just two parameters, passing but they have the same type, and I can like fuck it up. So I prefer to make them named. It's not a rule. You can do whatever you want, but this is like my small rule of clean code, which I always try to follow in my code. All right. So, okay, that's not it. What to do? Don't try. This is my notes, but I don't know anything. Okay, so the task will be create a function that accepts two doubles as position parameters, weight and height, and prints them out. Test it with the following scenarios. Pass the weight and height in correct order, pass the weight and height in reverse order. And you don't need to specify like real weight and height, just use any numbers. That's task number 1. I believe I have a task number 2 also. Task number 2 is create a function that accepts two strings as named parameters, day of the week and month, and prints them out, and test it with the following scenarios, passing them in correct and reverse order, the same as the previous one. Then the next task will be to create a copy of the previous function, but instead of making parameters nullable, give them default values. And the last one will be to create a copy of the previous function, but instead of giving params default values, make them required. And you can see all of the sample code also in Slack. All of the tasks and the sample code you can find in Slack.
What's the difference between this and this?
Okay, then the third one.
Is there okay also? Yeah, that would be also. But then, as I understood this stuff, like the make functions to require parameters, and this is the make function to require.
Yeah, I think it's the same. I will delete this because yeah.
It's the same.
Yeah, it's the same. It's the same. You are correct. I must have been thinking about some other thing and wrote the same task. Okay. Probably because you'll have to make them required. Okay, so forget about that one. You have 3 tasks.
you the difference between position point.
So the example at the top, the print full name, just the first one, print full name, they're positions because we have to pass them in this order. And all of the rest of the examples, 2, 3, and 4, the parameters are in those curly braces, and you have to give them names when you pass them. So look at the difference over here. I'll just quickly use first name. So in first case, print full name, we just pass them like 1, 2. Even probably this will be better to understand. But in the second option, we first say that the first name will be this and the last name will be this. So the syntax is different. So to make this more clear, in here we don't specify names of the function parameters. We pass them as position 1, 2. But in here we say that first name will be this variable and last name will be this variable. Is this clear, or should I explain more? It's okay if you don't understand, and I try to explain better. So, because in this case, in the first one, print full name, if I pass last name and name in this order, it will print username is Smith and last name is Alex, which is incorrect, right? And we want to avoid this. So, and there's no way for us to avoid this, only to pass them in correct order. But in the second case, I can say last name is last name, first name is name, and I can do this in any order that I want, as long as I specify that the function parameter last name corresponds to this variable last name. Да. Так, какое там было первое задание? Wait and hide and print. Да, первое это параметры без required, просто без кучерявых скобок. Да. А второе это уже с кучерявыми скобками. No, actually, that other function was the other task was correct, because there are 3 ways we can do something. For example, the first one, the print full name 2, we make those parameters required, right? So we have to pass them. The second case, or print full name 3, we make them nullable, but there's no default values. They're null. And the last case, they're not nullable, they're not required, but they have default values. Oh. So there are 3 scenarios. Супер. Тогда давайте быстренько еще пару моментов пройдем. Потом, если что, делаем перерыв. So up to this point, we have discussed only if we pass only positional arguments or only named arguments. But we can combine them. We can also make positional argument optional, but we won't be discussing this right now because it's not the super use pattern. You can look it up later if you want. Let's create a function called printPerson. And 2 things we can do. We can pass the name as positional, for example, string name. And then we can pass int age as required. As named, or actually, let's make it not required, but make it nullable. And do a couple of things here. So let's recap. We have created a function called print person. We pass parameter name of type string. It is positional. It is not in curly braces. It means that it's always the first parameter that we need to pass to this function. And then we have one optional named parameter called age. So let's do something with this information inside this function. And let's say if age is not null, print user name is 8 years old. Else, just print username is of unknown age. And now, when we want to call this function, here's how it looks like. Print person, because string name is positioned. We don't need to give it a name. So we can't do this. It will tell me that one positional argument expected by print person, but 0 found. So it always has to be a positional string parameter, which is first. We can leave it like this because age is optional, but we can also do it like this, print person. Anna, always positional first parameter, but we can make it age 50. And look at the combination here. Anna is without a keyword name, but age is with the keyword age because it's an optional named parameter. So if we run it now, you will see user Daria is of unknown age and user Anna is 50 years old. And you can combine them like this, like you want. This is also a questionable pattern, but you will see one of them very often in Flutter. So let's just look, take a quick glimpse. For example, text button. And we will have, this is like pseudocode. Of course, in Flutter, there's widgets and not strings, but just to see the pattern. String child, and optional parameters like string, color with a default value, for example, red. And then if we want to call this text button, say text button, some, I don't know, awesome widget. And then if we want, we can override the color with blue, or we can leave it as is. So this is a pattern that you will see often in Flutter, where the first parameter is always a child widget, because we will be nesting widget inside widget inside widget. We will do this a lot of times, you will get used to it. And then optionally, you can pass named parameters. So that's one pattern we will definitely use this a lot. Okay, and one last thing is up to this point. Up to this point, we have only created functions that are void, which don't return anything. So now let's just check how to work with return types. Let's say we want a return type string. And the function is called getFullName. And we will pass two required parameters, required string first name, required string last name. And in the body, instead of calling print, because if we don't return anything, the compiler will also squiggle in red and say the body might complete normally, causing null to be returned, but the return type string is potentially non-nullable type. So by default, if you don't specify any type, for example, in print person here, we can remove void. We can just leave it like this and it's perfectly fine. It will compile. But implicitly, under the hood, Dart returns null from this function. Why null is not safe, we have already seen. So it's a good practice to explicitly specify what type of this function will be returned. And in case of void, we don't need to return anything because it's a special type. But in case of class type, like string, we need to return it. So we will just use the keyword return, give it a string, my name is blah blah, last name is blah blah. And then if we go back to main function, we can do this file, full name, whatever, it always gives me random last names. And we can then just print it. And if we run this, let's just also comment this so it doesn't spam the terminal. And we will see that my name is Daria and last name is Kuzmina. So this way, we don't only have to print anything in functions, but we can also return values, and then we can do something with those values. Okay, and yes, one last thing that I wanted to show you regarding functions is that Dart is also quite smart. And for example, we have a function that returns a string and call it int to string. It accepts one parameter. And what it does, it's just passes back at the same integer that we gave it as a string, right? Pass it in braces and it's now a string, not an int. This is a very simple function. Like it's just one line. And because it's just one line, Dart it has a shorthand syntax for this. It's called fat arrow syntax. You will also see this a lot in Flutter. So what we can do is string to same way int value, but instead of opening curly braces, we write fat arrow, which is called fat arrow, or lambda, kind of a lambda in other languages, not exactly, but you can also call lambda, it's fine. And instead of writing return, you could just give it a value. And this is exactly the same as this. Exactly the same. And it doesn't always have to return a value. Also the void print line, string line. And let's say we would do this, but we can also do the void print line 2, shorthand syntax. Fine. And like this. So you will see this and this line are completely the same. They do the same thing. Okay, so now let's do a couple of tasks for keeping this in memory, and then we'll have like a 5-10 break. Okay, I will send you the tasks. I will do this from here. This was first task, create a function that accepts two doubles, some named parameters, weight and height, and returns the result of the BMI formula. And the formula is there. It's weight divided by height squared. Write the result in a variable in the main function and print that result to the console. This is number one. And then two tasks. Just a second. I want you to write two functions. First of them is following this pattern, write a function that accepts two parameters, a and b, and returns the result of a multiplied by b in two variations, one with fat arrow notation and one with a regular function notation, and do the same for the sum, a plus b. And as usual, when you're done, write a plus sign in the Slack channel so that I can check. And then let's have a quick break so you can grab a tea, coffee, so on. Also, I forgot to ask any questions about that. Do you understand the fat arrow notation, why it's needed and so on?
если ты что-то по свету, то что степени, или я не сильно.
Тут
Или
немножко другое. Нет, сделай просто height умножить на height. Помощь помочь. Что, понятно? Помощь. Потому что он сначала перед. Да, можно написать, в принципе, протестировать, но так вроде бы как-то. Так, что я хотела сказать? Yes, one thing that I wanted to say, important regarding programming in general, but I see something here, is we write code for other people, right? We don't write code for computers because computer doesn't care how the code looks. if it has meaning or anything. We can just write any random symbols, and to the computer, it's all the same in terms of naming, in terms of formatting, in terms of making code readable. So what you need to always keep in mind is that the code that you write is for your teammates and for future you. Because you can write code today, return to it in a month, and don't remember anything. You don't have any context. You don't remember what you were doing. So the more readable the code, the more clean it is what we call it clean code. The easier it is to work with it. And one thing related to clean code, to standards, to the team standard, is formatting. So for example, we can write code like this. Just take a quick look. Then you can return to your tasks. You can write code like this, all in one line, right? And to the computer, it's all the same. It doesn't care. It's all in one line and so on. But for you as a user, you have to read through like what, if, else, and then so on and so on. And for that exists code formatting, which is like some rules on how the code should look like. For example, all of the code inside the if should be in separate lines. So else and if should be only on their separate lines and so on. On the same way, you can like have a lot of spaces here or a lot of spaces here. And this is also makes it harder to read, right? So we need to agree that only one space after else, one space after a linked brace, and so on. Sometimes you can still make those mistakes, especially when writing a lot of code, and you don't need to format this manually because it's built in Android Studio. I believe it's built in VS Code. If not, then you need to install a plugin or something like that. But there is a tool for Dart and for other languages. For Dart, it's called specifically Dart Formatter. And in Android Studio, you can press on Max Option, Command, and L at the same time. And it will reformat the code for you. And it says formatted 13 lines. And it formats code according to the Dart effective Dart style code style. I will send you the documentation later on after this lesson. For now, you just need to understand that there is Dart suggestions on how to format code. And if you use option plus command plus L at the same time. Сейчас, я напишу в чате. Я напишу в чате. Сейчас сделаем. По-моему, по крайней мере, у меня так, но вроде бы это стандарты, комбинация. It will reformat the code. So if I had it like this, then I press it, it will reformat. And it's crucial to always make sure that your code is properly formatted. So for me, it's already an automatic habit. I write a piece of code, I reformat. I write a piece of code, I reformat, and so on. So the command is option, just command plus L. With Android Studio on Max.
Option это Альт.
Да, а у тебя Альт называется?
Да, у меня.
Мне кажется.
Альт, ты говоришь.
Да. Нет, нет, стоп. Вот это option есть.
Ну да, ну туда.
Да. Да. For you, it's okay. You understand?
Yeah.
Okay. Code-wise, are you ready?
Yeah.
Okay. Can I see? Okay. Yes, fine. Потом переписать сам проделанный какой-то метод и малый. Ну, все правильно просто.
Да,
Ну, я дам упражнение на дом в любом случае, поэтому это еще точно не сделать. Do you need a break or do you want to continue? Давайте 5 минут. 11:55 продолжим. Just today we will be learning Dart, and starting Monday we will be doing Flutter apps, so it will become more exciting than just writing functions.
It could be that I won't participate.
Okay. Okay, well, I will make sure to record it.
Yeah.
Yes. Or
But
you can join online too, if that works for you. You can do that, yes. It's just that it's offline first because I walk and help and so on and check. I stream, so it's streamed automatically. So I hope it's going to be fine because previous meeting was fine. But yeah, it's okay.
And side to recording, looking at
Chat. Yeah, I will. I will send. I've sent the yesterday ones. I
Yeah.
think you can find it, and I will
Yes.
send today and to next one and so on. Just in case we have more restrooms at the end of the office. Yes. Очень вкусная. Ешьте, это вам. Так. Okay, so now I think this will be a really easy one. Just a quick overview of how to work with if-else statements in Dart. So for homework, I want you to do, there will be a lot of tasks, and I want you to do the same. For each task, create a new file. It should have a main function where you test the functionality, and all the other functions are also in this file. So let's say I want to convert an integer to a weekday. So let's say string int to weekday. We pass parameter int day. And oh wait, valid. What there is many ways how to do this, of course, but we will be looking at if else. So we want to check if day equals 1, return Monday, right? Then else if day equals 2, return Tuesday. Blah blah blah, so on until day 7, and then we can either do an else. For example, if we wrote all of the 7 days and then some unknown number like 15 comes, we can say else return day not found. We explore 2 concepts here. First of all, if else. If else, it's really simple. If you have written in any other programming language, it's exactly the same. But the other thing is an early return. So for example, if day equals 1, we return Monday, and the execution of this whole function, it stops. It doesn't continue, it's just forgotten. For the last case, for example, we could skip writing else like this, and we can just return day not found. This will be the same thing because it will go through all of the if else, if else. If none of these branches worked, then it will just return day not found. Okay, we can test it. So I don't want to write it all by hand, so I'll just that's it. This one is it. I'll just quickly copy it. Don't waste a lot of time. So here's this function, right? If day 1, blah 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 blah, day not found. So let's just test it. We can do print to weekday. Do you not like? Oh, and to weekday. And if we run it, let's say Wednesday. We should see Wednesday. And if we pass 16, for example, unknown day, it will say day not found. So this is a basic if else statement. And one last thing that I want to show here is also how to call functions on classes. So let's say we want to see if we want to print. Yes, we want to print if the number is even or odd. So we would say void print even or odd. We pass it an integer value, and here's what we can do. We can say if int if value, and I can see that value as an integer has a lot of kind of functions, field names, and so on. I can do a lot of things to this value, right? Because it's an integer. Each class has its own set of functions and fields. So what we can do is we can ask value is even. If it's so, then print even. and else print odd. This is just a simple demonstration on how to call functions and fields on classes, on objects classes. So we can test it here. Print even or odd. Let's check number 2. If we run, we will see that it says even here at the bottom. Oh, I can make this bigger. This is nice. So yes, and then here the 1, 3, it will tell me that it is odd. All right. I think we won't be stopping on this right now. It's pretty obvious. We will still continue doing this in other tasks. And let me check. Yes. Next thing that we are going to look at is collections and loops. So up to this point, we have worked only with one value, for example, one integer, one string, and so on. But what if I want to have like a list of all of the days of the week, right? So I'll create a new file. And for example, I want to have a list of weekdays. I can do list, in this case, string, call it day names. I'll explain the syntax in a second. And give it a value. So how to create a list? First of all, we need to specify that this will be a list with the word list. And then in those diamond brackets, we specify what type of variables will this list hold. So in our case, it is string, right? Then we give it a name, day names. And we can, and to just create the actual list, we need to use square brackets, just like this. For now, it's an empty list. Let's just verify by printing it. Here, and we can see that it prints just an empty list. And we can give it values. Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, blah, blah, blah. So nothing special here. But if we run it now, we will see that it's prints Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, and so on. We can also create list of other types. For example, list int, day numbers, and print day numbers too. And if we run this, we say Monday, Tuesday, blah, 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 1, 2, 3, 4, 5, 6, 7. This gives us a lot of things that we can do with it. For example, we can add values to those lists. So let's say day numbers. I want to add, no, not day numbers, day names. Names, and I want to add a new type of day and call it today. Okay, and now if I print day names, I will stop on this. I will see that now my list contains Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, and today. The same way I can remove. Actually, I'm sure it will work on this. Let's see. Oh, I didn't print anything. Print it after. It works. So we have added today, we have printed it, we have removed today, and we have printed it. I can also add several. Add all, for example, today and tomorrow. Let's print it. And now I can see that it has also today and tomorrow. Now, for example, I want to know what is at which position in this list does Monday variable exist. I can do it like this. It's called index. So I say final Monday index. I take my list, the names, and there's a function called index of. and I pass the value of the index that of the value that I want to find the index of. So if I print Monday index and run it, I will see that Monday index is 0. Oh, oops. Let me make it bigger. Also, if you can see something, stuff like that, just let me know, because sometimes I can just go on and not notice things like this. So Monday index 0. And lists, as in all of the programming languages, I believe, counting starts with 0. Not with 1, but with 0. So Monday is 0, Tuesday is 1, Wednesday is 2, and so on. But what happens if I ask for an index of something that we don't know? For example, index of unknown. Let's print it. Any ideas what it will print? Okay, let's check. And we see that unknown index is -1. Slugs, yes, -1. So whenever you try to find an index of something, and if it doesn't exist in this collection, in our case in the list, it will print not print, but it will return you -1. So -1 means that this item doesn't exist in this collection. Okay, so what useful things can we do with those lists? For example, what if we want to print like all of the days of the list? We could go on like this, print day names, and for example, to access an item of the list, I write the name of the list, followed by square brackets and the index that I want. So, for example, like this. Then I can change it to 1, 2, 4, 5, and print the first 6 items. So let's see, and it prints Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday, right? But this isn't really scalable. What if I will have 1,000 items, right? Or what if I have, for example, what if I try to access number 30? See what happens. What happens is I have an unhandled exception called range error index, invalid value, not an inclusive range, because it shows that we have items from 0 to 8, and I try to access 30, which is not safe, obviously. So this doesn't work and should probably never be your selected option of how to do things. For that, we have special. I'm not going to. Why? What are you writing? For that, we have special constructs called loops. Also, probably if you have worked with them in other programming languages, this won't be something new for you. So the default loop, the one that you have probably all heard about, is called for loop. So let's say for, and I equals 0. So we start with an index of 0. And we go through this loop while it is less than the length of day names. And then after each iteration, we increment it. And every time we just access the I index and print it. So I'll just comment all of this code that prints stuff so that it doesn't pollute anything for us. And let's run it. And here I can see that Monday, Tuesday, blah, 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 today, tomorrow, all of them are iterated. That's one way to do this. A next way would be what is like a for each loop, and it's a shorthand. Instead of actually creating a variable to access, like an index, in this case I, we can do for the type of variable in the list and give it a name for string day in day names. And it gives us access straight to the actual variable without accessing just the list like that. So if we comment this loop, run it, it has done the same thing. Printed Monday, Tuesday, Wednesday, Friday, and so on. Okay. Any questions about for loops lists so far? Okay, I'll clear that. Okay. So there are 2 more types of loops. Also, probably if you know for loops, you know while loops. So let's say we have var I equals. Actually, no, what we can. No, it's var I equals 0. and bool, not bool, string wanted date. And let's say Wednesday. Okay. And then we can write we can do a couple of things here. First, we say while e is less than day name's length, same way as in for loop, we check if the variable at this index is the same one that we want. And if it's true, we print where is it located. And we use a special keyword called break. And what breaks does, it just breaks the loop. So it doesn't care about what happens in here. It just stops the loop. Otherwise, if it's not true, if it's not found, we iterate I, increment I, and go over again, go with the next iteration of I. So let's run it. And it says that found Wednesday at index 2. And to verify that it has broken, we can say else print not found once a day at index I. It's a bit laggy. So, and if we run it now, we can see that not found Wednesday at 0, not found at 1, found at 2, and no more text. Means that the loop has different. Because if we remove this break, for example, we comment it. Remember, right, that we found Wednesday at index 2 here, and there's no more text. Nothing was printed. So if we run it now, we will see that found Wednesday at index 2, but then also not found Wednesday at 3, 4, 5, 6, 7, 8. This is what the break keyword does. Okay, any questions about that? Okay, and then there's the similar concept. Do something while something. Difference from the just while happens? What happened? Equals. Sorry, something wrong with syntax. I don't remember it, so let me quickly check it. Oh yes, that's me. That's me being stupid. So yes, we can do the body of this loop executes at least one time, and the while is described after it. And in case of this specific scenario that I have wrote, it's also a dangerous one, because if there is never a Monday in the wanted date, this will be like this loop will go on forever and forever until I terminate the program completely. So you have to be really careful with your conditions in the while loops. For it too, but for it's not usually a problem. But with while loops, definitely, because you can have any condition that you want, and sometimes it can lead to being always. Okay, any questions about that? Then let's do a quick task. Oh, I haven't shown one last thing. Let me quickly show you one last thing. And that thing will be to check if there is anything, if there's a value that we care about in the list. For example, final contains Friday. We can check day names, function contains, and Friday, and print contains Friday, contains Friday, and just for a check, contains unknown, and contains unknown. Just a simple function contains. So let's run it. And we can see that contains Friday true, contains unknown false. One important thing about list and their contains method is that potentially this Friday, or in case of a null, we have to go through the whole list to find out that it does not exist, because we go, okay, check if item 0 is unknown. If not, then check item 2 if it's unknown. If not, go to item 3 and so on and so on and so on and so on until the end of list. So if we have 1 million items in our list, this can be really slow, or like 10 million items or 100 million items and so on. So the complexity of to find whether an item exists in this list grows with the count of items in this list. This is something to keep in mind because we will be looking at one more data structure soon. But for now, let's do the task that I've sent you in chat. So create a list of 6 months. First list should be of type string. Second list should be of type int. Third list should be of type dynamic. I haven't showed you this as an example, but you can try and do it yourself and try to fill in this list with different kind of variables, strings and ints. Print all of those lists, and the following instructions you can see that add 3 ones to the first list one by one, and so on. This is to practice calling the methods of the list, like add, remove, index, contains, and so on. And I also believe that I wanted something else. Yes, and for loops, write the same for loops, but just search for any wanted month that you want. Видела, нужна помощь какая-нибудь? Okay.
Does using break is good practice? Does it make some
For if else,
confusion to code sometimes?
using braces.
Break.
Break. Depends. I would say depends. Depends on how you write code, how big is your function. So if it's like a 3-line function with the one break, it's okay. So yeah. But in general, like early return practice is something that I use often, because it's allows to make less nesting. For example, if we enter a function that has a value as a parameter, we check that this value is not correct. We just do return before we go continue into code. So breaking code in terms of like early returns is fine. With break, it depends.
Can you please show us how can I add something like print function? If I want like add string and concatenate this function. Because I had 2 string that says that please use a different approach.
Okay, can I see what are you doing?
Just like
Okay,
full
yes,
sentence.
I understand what you mean. Yes, for that, it's really similar to what we have already done. For example, I'll just copy contains and now. And instead of actually variable, I want to calculate it in place. I just wrap it with curly braces.
Oh, okay.
And then I can do any calculations inside like this. Or just I don't need the, yeah, like this. Yeah. Скажи. Да, только в динамик, например, можешь после June добавить цифру 7. Кстати, да. Да. Вот один раз так делала, а больше так никогда в жизни не делала. Могут быть проблемы. Да, все, супер. Все нормально? Двигать дальше. Вспомнить, что там было дальше. Okay, so up to this point, we have discussed a list. That's one kind of data structures. And for example, if we want to add another Monday to our, okay, now let's move on to a different kind of list. So where is my task? Let's say that I have a list of colors, right? Red, green, and blue. And I want to print it just to make sure that it's true. And I see here, red, green, blue. Nothing stops me from adding one more red. Okay, not yellow, red. And if I print it now, I will see that it has red, green, blue, red. And sometimes this is not convenient. Sometimes you want to make sure that no matter how many times you add the same value, if it already exists, it should not be added. So there are a special data structure which holds values that are unique. And if you try adding values that already exist in this data structure, it won't be added. So this data structure is called set, and it looks like this. It's really similar to the list. The difference is we say set instead of list, so it's like a set of items. And instead of what are they called? Rectangle braces, we use the curly braces, not square braces. Square brackets, braces. Too hard. So yeah, we use curly braces instead of those rectangle ones, right? And let's print it out. Let's comment the listings, but let's print out the set one. Print color set. And if we run it, we see that, okay, it has red, green, blue. Now let's try to add two more colors. One more red, and also one more yellow. So not one more yellow, but a new yellow. There's no yellow yet. And if we want to print it now, what do you think you will see? Okay, let's see if it's an error or red, green, blue, yellow. It is red, green, blue, yellow. Set is smart like that. It understands that this value already exists and it just doesn't add it. So that's one thing where to use set. For example, if you want to make sure that all of the values are unique, but also, one more thing, it's just something to keep in mind. Remember when I said that if we try to find if an item is contained in the list, there's a possibility for us to go through the whole list. And if there's like 1 million items in this list, it will be really slow. In case of set, we can also check if an item is contained in the set exactly the same way. Final contains red like this. And let's say print object contains red, just to check. And it says true because there is red. But the way set works under the hood, and I will send you an article to read at home, which I wrote a while ago, which explains this in more detail. It's a bit advanced, so don't be intimidated if you don't understand it at once, but in the future, it will be really important so you can return to it again and again. But the way set works, and it contains works, it doesn't go through the whole set. It knows how to check in one iteration. So if you ask set, does it contain red? It doesn't go through the whole items, but there is a way for the set to know that yes or no. So it's just 1 second. Let's imagine that for each check of the item in the collection, it takes 1 second. So in case of a list, potentially, if with 1 million items in the list, it would take 1 million seconds to find if an item is contained in a set, which is some kind of a lot of hours, which is really long. But in set, it's always 1 second. So also, if you in your code need to do a lot of checks whether an item is contained, maybe consider using a set because it will work much faster. And set has also a couple of interesting functions. Set is the same as in math. I'm not good at math because it was ages ago. I don't remember a lot of stuff. But with sets in discrete mathematics, you can do a lot of things like unions, differences, and so on. So you can find whether there are items that are the same in two sets, items that are different in two sets, and so on. And this data structure also has the same thing. So let's create another set of colors. Call it colors set 2. And it will have also green, but also pink and orange. So we have one same color, both of them have green. But the first one has also red and blue, and the second one has pink and orange. So what we can do is find all of the colors that are in both sets. So we can say color set union and pass it another set, and let's check what it will print. Does anyone have any ideas what will be printed?
Union. Oh.
Yes, and what will it be?
Oh, like all unique colors.
Okay, let's check. And we can see that it has red, green, blue, yellow, pink, orange. But it has only one green, even though we have green both here and here, right? We remember we also added yellow here and added red here, but still it only has unique values. Because it creates like a new set. So union is also a set, but that has all of the unique values of those two sets. Okay. There's also an operation called intersection. Any ideas what it will print? Okay. Any other ideas? Everyone agrees? Let's see. And we see that it prints green. That's correct. And there's one last operation called difference, but we can call it depending on which set we call it on, the result will be different. So different. So for difference 1, we say color set and find the difference from the color set 2, and let's print it. Let's see what colors we have, and anyone has ideas what will be printed.
Green, blue, red, blue.
Okay, let's see. Red, blue, and yellow, because we also added yellow later on. Okay, that's correct. And final one, difference 2, we will call it the other way around. On the sets 2, we ask the difference from the color set. Okay, and now ideas. What will be printed? Here is set 1. Here is set 2. We also added yellow to the set. Okay, let's check. And is that correct? Pink, orange. It can, it takes some time to figure out, but once you do, it will be really easy. I'll just quickly find the article to show you a demonstration. Okay, so here is a union. We have set A and set B. Set A has blue and pink. Set B has pink and red. So the result is all of the unique colors: blue, pink, red. Okay. Intersection. They still have the same colors: blue and pink for set A, but pink and red for set B. And intersection is where the only color that they have the same. It is pink. And finally, the difference, for example, difference of set A to set B, it only shows the items that are present in set A, but are not present in set B. And that will be blue. Okay, so with images, you can study it at home. It will become much more clear. I believe this is the same as in mathematics. All those intersections and those, I don't remember what those symbols are called in English because, yeah. Okay, that's it with set, I believe. Let's do one quick exercise for sets. And this exercise will be following this pattern. Create 2 sets of planets. You can add any planets that you want. They should contain some similar planets, but also some different. Do the following operations and print results: union, intersection, and difference. For you as an exercise, before actually printing out, try to think what will be printed just for yourself. and then try adding the same planet to the set, and try adding the same planet to the list, print them, and see what happens. I will also send all of the code to chat. So while you write, a couple of things to consider when selecting a data structure for your use case. Whether or not your values should be unique. How often will you try to call contains to check if an item exists in the collection? And whether you need to do manipulations such as unions, intersections, and differences. That's it. Okay, with that, we finish with collections and loops. There's one more collection called map that you will probably hear about, but we won't be looking at it today. We will look at it in the future for sure. If you know it, good for you. If not, don't worry about it. So what we will talk about now is enums. So, but before we do that, let's try and see how we would write a function that would return a boolean, whether the day that we passed it is a work day or not. It's a working day. So a working day is Monday, Tuesday, Wednesday, Thursday, Friday, right? So for example, we would want to check return true. Okay, if day equals Monday, right? But what if we write the day Monday like this? Monday with the big letter, right? It's also Monday. And what if we write it day like this with all caps? Or month? For example, okay, this case could be, for example, simplified by us just saying day to lowercase and check with Monday, right? But what if we also pass just month? So day equals month, or just M, and so on. So there can be like a lot of different ways for us to say in a string that the day is Monday. And this is just Monday. We also have Tuesday, Wednesday, Thursday, and Friday. So it would be a really, really big if we want to check all of the potential cases to realize whether the day is a working day or not. So for cases like this, there is a special type of class, let's call it that, called enum. It's a keyword enum. It's a really, really lightweight and simple way to create an enumeration of things that are connected somehow logically, but don't have a lot of fields or anything. They can have just one field. So a weekday is a great example because there can only be Saturday is not. No, it's a weekday, but okay. True. Weekday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. There's no more option, right? So now our boolean is working day can accept, for example, not a string, but an enum called weekday. And in order to understand whether it's a working day or not, we could use another statement, control flow statement, which is called switch. Also the same as in other languages. So if you pass, for example, day to this switch, you can do something like this. So let's walk through this code. What we do is it's a special construction that takes something that it can iterate over. In our case, it's an enum, weekday. And we say, in case the weekday is Monday, or in case the weekday is Tuesday, or in case Wednesday, Thursday, or Friday, return true. In case Saturday or Sunday, return false. There is no need for us to check whether it starts with M, if it's one letter, 3 letters, and so on and so forth. We can just check one thing. And also, this is a shorthand syntax called falling through. So if it's Monday, Tuesday, Wednesday, Thursday, or Friday, but after each case, you can do a return like this. It's just a lot of code. It does the same thing, but it's easier to read when you just have it like this. It means that all of those cases will be the same. And if we test it, let's say final is Monday working day. We can press Monday and final, we can print, and let's do Saturday. So what we should see now when we print is true and false, right? Okay, let's check it. And yes, we see true and false. So it's easy like that. No. Yeah, that's pretty much it with switch statements and enums. We will do a small exercise right now, just so that you also type it out. And the exercise will be, yes, this one. I'm sending it here. So create an enum month and create another enum season. Create, so for in enum month, you should have 12 months. In season, you should have 4 seasons. Create a function that returns type season, and it will return a season for a given month. So parameter to the function is month, but return type is season. So for example, if you pass month January, it should return that season is winter and print the name. Oh yes, one thing I forgot to show you. Going back to my console. Yes. For enums, we can not just do fall throughs like this, but we can also print some things about them. For example, final Tuesday. I will create an instance of Tuesday, and I can print its name, and I can print its index. It goes out of the box with the enum. So this is what enum gives us. It gives us some comprehensible kind of title. We can also print it as a string and find the index of it in the enum. So it says true, false, and it's Tuesday, and index is 1 because 0 is Monday. Okay, now you can start your task. And help and explanation. Yes. Don't be shy to ask. Yes, also, I didn't mention this explicitly, but enums and switches make code safer, because if you forget to write a case for some kind of enum value, compiler will scream at you that it's not handled. This way, there's no way for you to forget, because, and if you don't want to handle specific cases, for example, you only care about Monday, Tuesday, Wednesday, and Friday, you can also fall back to a keyword called default, like this. And for every other case that is not described here, it will return this value. Okay. I will also send this to chat. Да.
Типа, если убрать вот эту в конце, а чисто только в свече,
Да.
то он типа
Потому что индекс это просто интегр, да, и интегров у тебя может быть там до скольки, 2 в какой-то там степени, 32 ракон. Вот. А тебе нужно не integer, а просто сам month. То есть вот там ты switch month index. Нет, не тут. Не тут, не тут. 30-я строчка, 30-я. Вот, и тут убери индекс вообще. Вот так вот. И тебе нужно делать не кейс 2, а кейс month January, например.
Ну, типа нельзя сделать так, через индекс.
Через индекс.
Через индекс.
Нет, потому что индекс возвращает тебе просто int. У тебя int значение от 0 до... Ну, то есть, если ты пропишешь все integer значения, сколько их там тысяч?
Ну да, ограничения.
Да, вот.
А так типа
Нет, нет. На это, поэтому нужны enums, они позволяют тебе ограничить вот этот вот скоп, какие значения нужно хендлить. Потому что, как и со строками, строк вообще может быть великое множество, и тебе обязательно нужно будет давать дефолт. А дефолт не всегда имеет смысл логически. And then, oh. Нет, это все. Оно name такой, ну, то есть это, ладно, в общем. Можно вот такой, дальше будет, да? Ты можно дать просто все. В таком случае ты назови его. Ну, это название, просто name, а он именно само название, а просто сам. Все логично. Also, another not like a rule, but okay, I stopped sharing for whatever reason. Another convention is that even enum titles should be starting from small letter, because if I do it like this, it will scream at me that the constant name Monday isn't a lower camel case identifier. Try changing the name to follow the lower camel case style. We will later on in Flutter take a look at all of the warnings, because there is already a lot of warnings, and see why we need to avoid them and why it should always be 0. But for now, it's okay. All right. Do you want a small 5-minute break, or can we continue? Continue. Okay. Let's have a super small, like, 5-minute break, 3-5 minutes, and then we'll continue with the last topic for today, which will be classes and objects. And with that, we will also iterate all of the concepts that we have discussed today. So, okay, let's say 2023. Come back. So, small break.
Final task for
I was thinking about it, but no, because during the whole course, starting from Monday, when we will start Flutter, you will be doing at home one specific app. So it will be like a book library app, and with each lesson, we will learn new things, which you will be adding to this app. So at the end, you will have this big functioning app. Well, big depends, but yeah, and this will be your work. But also, I wanted to say that if you have like a lot of time and you also want to try your own applications not related to this course, you can use this month to ask questions from me to get reviews for your personal apps if you want to do that and so on. So yes, homework will be for specific app, but if you want to do something on your own, you can also do that and ask me. Okay, we can start our final thing for today. We will discuss classes. You all know, like, at least in theory, what class and object is, right? Okay, this is good. Screen. So here is this big task that we will be creating. So this last one will go with stop. It will be follow along. So please follow the code along with me. I will go slower. I will stop so that you will have everything in place. But just for now, follow along. So there's 12 steps, and we will go step by step. So it says, first step, create an abstract class vehicle. Vehicle, I believe. I don't know why I came up with a task with a word that I hate in English because it's hard to pronounce. But anyway, I did that. So okay, let's do this. Abstract class. Okay, and in programming in general, abstract class is a type of class which describes some kind of behavior, maybe variables and functions, but it cannot be instantiated. So, for example, if we have a string, if we have a string, we can see that it's also an abstract, also final class. Don't worry about all of this code in here because it's actual real source code, so there will be a lot of it, but just see that it's also a class. And for now, also don't worry about final and other prefixes. Before Dart 3, which was before this May, you could only create abstract class or just class. There was no keywords like final, interface, base, and so on. So until very recently, you could only create abstract class or just class. We will follow this for now. In the future, also in the second half, we will take a look at other types of modifiers, but for now it's just classes and abstract classes. In Dart, it's an interesting thing that you can, if you are familiar with object-oriented programming concepts, and in Java and languages like that, you can both implement and extend the same class. So in Kotlin, in Java, for example, you would write something like interface, like this, and you could only implement this. You could not extend this. And the same way for just like class, you could only extend this, but you could not implement this. Dart is different in this regard, and you can both extend and abstract and implement vehicle. We will look much deeper into this throughout the course, so don't worry about this. Okay, so at this point we have created abstract class. point number 2. You're all following along, right? You all have this in your code. Okay, cool. It should have private fields, int max speed, string modal, and string color. In Dart, also, privacy is a bit different than in other languages, and it's private to the file, I believe, or even to the package. And there's no keyword like private. You can't do this. The way it's controlled in Dart is by using underscore, like this. Oops. Just wants to implement the whole thing. So I will write it and then we will talk about it. Okay, so when you prefix with an underscore like this, it means that this will be visible only, I think, in this file. I'm not even sure exactly, but yes, I believe in this file, not just to the class, just to the class. And there's no such thing as protected. If you are familiar with protected in other languages, there's no such thing in Dart. So, what's next? Make those fields accessible via getters and setters. So if you are also familiar with other programming languages, you should also probably know the concept of get and set. And get and set is a special concept that allows you to control how the variable is changed, modified, or if it can be modified at all, as well as it can do some calculations or validations before actually returning you the value from getter. So there's also a special syntax for that. As you can see already, it says int get max speed and max speed. This is the same as if you remember we did in the beginning, but do it like this. But this is a lot of boilerplate, and we can just use the fat arrow notation like this. And let's do the same for the other ones. String get model. Oops. If at any time you need me to stop, please tell me to stop. And one thing that compiler is currently screaming at me is it says non-nullable instance field max speed must be initialized. Remember, like we did at the very beginning, if we mark something as not null, then we should give it a value. But the same way as we did with final, we can keep the value unassigned at the time of not initializing, but declaring, promising to the compiler that the first time when this variable will be accessed, it will already have a value, and we do this with the keyword wait. Same way as we did with the final. It's the same thing. It says that, okay, I am declaring those variables right now. They are non-nullable. They can never have null values. But at the moment of creation of this class, I don't know this value, and I promise you that I will give it to you later on. What happens if we access a variable marked with late, but which has not been initialized? Compiler will throw an error. It will, depending on how you do it, it will either throw you a compile time error saying that this value is definitely not initialized if the code is pretty simple. But in more complicated cases, this can be a runtime error, which will lead to more problems because it's not necessarily that you will find it. So just to recap, there's two types of errors. Compile time errors. These kind of errors we love because they don't allow us to compile the app without fixing it. So if it's fixed, then it works. So these are good kind of errors. And then there's bad kind of errors, which are runtime errors. And they happen when we actually run our code and some condition happens. They're bad because they're unpredictable and because we don't always get them. So it may be while we're testing, everything is okay, but some specific condition in production for a specific user, and you get a runtime error, and which is bad experience, and users will come back screaming at you and putting 1-star reviews in Play Store. This can happen. Okay, now let's write setters. So we got, for now, we will just return the same value as it is in here. and we will give it more logic later on. And let's write setter. So setter is just what allows. Why are you asking me? Okay. Again, when it squiggles with yellow things, it's just a warning. It's not an error, and we will return to warnings later on when we will be discussing linting. Okay, so for now, also a special syntax: set the title, the value that we want to set, and for now we just assign the value. Later on, we will add some checks. And let's do the same for the rest of the fields: the model and the color. Everyone's okay with that? Okay. Next point. Add a method called isValidSpeed that accepts speed as a parameter, which is an integer, and returns a Boolean result that checks if speed is less than max speed. I can send those small tasks also in chat so that you can see them, or I will just send the whole thing, and I will tell you at which point where we are, so that maybe you want to also try to do something yourself. But for now, we are doing adding a method isValidSpeed. So it is a Boolean. Bool isValidSpeed. And it's asking the parameter that we need to check is speed. And we need to return whether it is as less than max, less or equals to max. All good with this? Okay. Also, you can just say like done when you're done, so that it's easier for me to understand. Let's quickly test one hypothesis. As can we instantiate a class, an instance of a class vehicle? So let's say final. You don't need to write this for now. For example, I want to create vehicle, right? Like this. But it will tell me that abstract classes can't be instantiated. So there is no way for me to do this right now. And you will ask then, what is the use of this vehicle if we can even create an instance of it? Well, use is for it to provide some behavior that can be shared by other classes that extend it. So going to point number 5, let's create a child class bus that extends vehicle. So we will do this. Now you can follow class bus, not bus, but bus extends vehicle. This time it is not abstract because vehicle, even as a notion for us, for the human language, is pretty abstract, right? It can be anything. It can be a bus, a car, a motorbike, and so on. But bus is very specific. We know that what bus is and what it behaves like. But still, all vehicles like bus, car, motorbike, they have similar things like maximum speed, modal, color, and many others. All right. So next thing is we need to add a new field, seating capacity and field seats count to the bus class, not to the vehicle. Okay. Let's do this. And seating capacity and wait int field seats. Okay, let's do this, and now let's fix this. Because from the logical perspective, seating capacity is something final, right? So if the bus has 50 seats, then probably you can't add on like more seats to it, only if you completely redo everything inside. So we will make this int final, late final, like this. For now, late final. We'll see soon why we'll remove it too. And instead of field seat count, probably for initial bus, it is always 0, right? So we can actually not make it late, we just give it a default value. So it will have default value of 0. So field seat count is 0. Are we here? Okay, this is also text for now. Let's add getters and setters also for these fields. Well, for seating capacity, there will be no setter. Let's just add a getter. And I will show you soon how you will fill it in with some value. So the same way as we did with the just vehicle class, same getters and setter only for the field seats count. Okay, so far so good. Or need help? We're doing this walkthrough so that first of all, we reiterate some of the concepts that we have learned already through today. We will also learn some new ones, like for now, getters, setters. We will also learn constructors, exceptions, and so on. And also just to get on some more tangible example in your code base, and you will do similar homework. Okay, so the next point is in the setter of field seats count, check if the number, this one value, is less or equal than seating capacity. If it's not, throw an error with the message not enough space. Because we have a seating capacity, and if we try to set field seats count to more than seating capacity, this is illogical, right? So this should not be allowed to happen. And this is one of the reasons why we can have setters and not expose our variables just as they are. So let's check if value is less or equals than seating capacity. Then we just allow this value. That's okay. But otherwise, if this is bigger than seating capacity, let's throw an exception, not enough space. And throwing an exception is literally done the same way as it sounds. It says throw exception, and as a parameter, just has a message. Now, everyone okay with this? Okay, let's try and test something. Let's create an instance. For now, you can watch. For testing, you can watch. We can create an instance of bus, right? Now it compiles because it's not an abstract class. And now let's say we want to set the bus field seat count to 50. I don't know. Okay. And let's just run and see what happens. Maybe any ideas? What will happen?
There will be error.
Okay.
Because the thing you use the private variable, not the getter.
Actually not. Getters and setters are okay like this because C sets and field seats count, and those special keywords allow us to access it like a field. But
You don't must.
okay, that might be true. Let's check. Unhandled exception. Oh, yeah, I see it sooner than it shows on the screen, so that's why I spoil it for you. We have an unhandled exception, and it says late initialization error. Field seating capacity has not been initialized. See, that's what I told you, that we promised the compiler that seating capacity will be filled in sometime in the future. But we actually haven't written any code that fills in the seating capacity, right? But already in the setter, the field seat counts, we try to access it. And we get an unhandled exception that it is not initialized. But it's compiled and it let us do this code. So this is bad. This is not safe. Let's make it safer. First of all, let's remove the late final. Okay. And now it screams at us saying that the final variable seating capacity must be initialized, which is true. It is as it works as it should work. And what is a way for us to tell this value and make this value variable, right? Because buses can be different. There can be small buses, big buses, and so on. So we can pass this value in the constructor. So every time that we construct a bus, we need to pass it the seating capacity because it's a crucial information about the bus. And how do we do this? Let's add some lines here. And we say bus. Like this. Now it's screaming at me, it says all final variables must be initialized, but seating capacity isn't. So there's a couple of ways we can initialize. We can do it like this seating capacity, or not, because I don't know how to write correctly. We can do it like this, seating capacity. And this is a special keyword that's telling us that whatever you pass to the bus constructor will be assigned to the field of this class, seating capacity. That's one way. We will look at another one. And if we go back to our main function, we can see that now it screams at me that bus wants one positional argument, but 0 found. So let's pass it 25. Okay. And now let's run it and see what happens. So what happens is we have an unhandled exception, not enough space, just as we promised. Okay, and if we test with another one, giving an seating capacity of 75, nothing happens because it's just around the program smoothly. Okay, so far, any questions? Okay, but what will happen if we want to print, for example, the color of the bus? We can do that, right? Because bus extend vehicle and vehicle has color, right? And model and max speed, we could do that. But any ideas what will happen here?
is again not initialized.
Okay. Yes. Late initialization error, field color has not been initialized. So that's why late variables are sometimes good, but can shoot you in the leg. So you have to make sure that you initialize all late variables. And this is how we can do it, because we want to make sure that we pass them to the bus, but the bus extends vehicle. It doesn't have its own fields. We need to call the what's called the super constructor. Super is the superclass. For bus, the superclass is vehicle. Okay. So it's like bus is the subclass of vehicle, but vehicle is the superclass for bus. Or it can also be called bus is the child class of vehicle, and vehicle is the parent class of bus. So the syntax is like this. It's called super, but it also doesn't ask for anything. We can now return back to our vehicle. And okay, no, we're not going to make them final. Forget about this for now. Okay, so let's just return back to our super constructor. And there is nothing that we can do about it, because we still need to tell vehicle how to set those fields. They don't have to be final, but we still need to create a constructor that allows us to set those fields of the vehicle, right? So how we can do it? Again, we say just title of this class. So there's, I don't know if it's the same in other languages, but there's no special like new or constructor keyword, none like that. It's just the name of the class itself. It already understands that this is a constructor. And let's make them named. So the same as with functions, we wrap them in curly braces. And what we do here is we pass what to pass? We pass 3 values, but we don't want to give them any default values, because it doesn't make sense. Vehicles are all different. What we do is we want to make them required. Remember, the same way like we did with functions. We always forget the syntax of constructors. So it looks like this. First of all, in the constructor, we pass the variables, and then the same way as with the function, we create a body, and in this body, we assign the local variables. So this one, the variables that we have passed in the vehicle constructor. Okay, everyone good with that? So now there's what we need to do now is to actually give a possibility to the bus to also fill in those fields. And if we return back to our bus and to its constructor, we can see that now we can't just call super like this, because it screams at us the name parameter color is required, name parameter max speed is required, and so on and so forth. So what we need to do is we need to pass those parameters also to the bus. And what I prefer doing is, because we already have 4 parameters, right? So we need seating capacity, we need color, we need max speed, and we need model. It's already a lot. So I prefer making them named. So instead of doing this seating capacity, I would remove this and write all of the parameters that I need in here, which is required in seating capacity, required in max speed, required string model, and required string color. Yes, a couple of things. Without getting into too much details. I have done a little bit of refactoring here, and I will explain everything to you right now. So the way final works, and this in constructors, it doesn't allow us to make it named and private. So it can be named and private. So what I did is I made seating capacity not private, but final. It doesn't matter because it's final and you can't change it anyway. So that's why I made seating capacity not final, and I removed the getter because it's now the same field. And in the constructor of bus, switch that off. In the constructor of bus, there are two things to notice. First is that we are setting our own field via required this dot seating capacity. But then other parameters are not this. They're just parameters. And then we pass those parameters to the super constructor. It all may sound look a bit confusing right now because this is your first time doing this. It's completely fine. I've been working with Dart for 3 years and I still don't remember the syntax of all of these super and so on, because sometimes you can have super and also a body and do stuff there. So it gets confusing with all of the braces and so on. So don't worry about this. You'll practice, you will do this at home much more, and it will make more sense. You will have more time to study. But so far, do you have the same code? Okay, great. Now it screams at me that bus 75, it says too many positional arguments, 0 expected, but 1 found. So what we need to do is we need to fill it in with all kind of parameters. And let's fill it in with those parameters. So seating capacity 50, max speed 100, modal BMW, and color green. Or you can fill it in with any information if you want. Okay, all good. Works for everyone right now? Okay, so now we have checked a lot of new concepts. We have checked the concept of classes and abstract classes, of extending classes, of private and public fields, but there's a caveat with those privacy, because if you take a look, I can also do this. See, and it's completely fine. That's because it's private to this file, not to this whole, not to the class. That's why there's not like real privacy. Sorry. So it's only nominal. Well, not nominal, but yeah, not super useful. And we have also learned how to throw exceptions, getters and setters. And yeah, pretty much that it. So for homework, you will need to continue with this task. There will be also other tasks, but you will need to continue with this one. I will make a Jira task and so on, so don't worry. It will be also all there, but I just want to walk you through right now. So to continue, we will need to create a child class car, and you can also add any other new fields like we did with capacity and fields and seats. You can add new other fields to car, for example, type like electric or hybrid or whatever. You will also need to create an enum called license type. It should have values car and bus. You should create a new class, completely new class called driver, and the driver should have fields such as string name, license type, license, and list of vehicles, abstract vehicles called own vehicles. It should have methods can drive vehicle that accepts a vehicle and checks if the driver can drive the specific type of fast vehicle. You will have to check yourself how to check whether a vehicle is a bus or a car. It's simple. It's done by Googling, but you will have to do some small challenge. And compare it to the type of license that the driver has. So for example, if I have license type bus, it also means that I can drive a car. And you can check if the past vehicle is car and license type is bus, true. If license is car, but the vehicle past is bus, then false, I can't drive this vehicle. And it also should have, the driver should also have methods add vehicle and remove vehicle. That adds and removes vehicles from the own vehicles list. Okay, any questions about this? Okay, there will be also smaller exercises just to practice with your hands, similar to what we have done in class. And there will also be, as the previous one with Confluence, a theoretical one with questions. for exploring. All right. How do you feel about today? A lot of new information. Stuff to digest. Okay. Yes, you will have a whole weekend to check it out. So yeah, we didn't get to dive too deep into programming fundamentals because that's what was asked, to have understanding of basic things, but I think you all did good. And with practice, with time, you will get a quick hang of it. So after your homework, I think you will feel even more confident. Yes. Okay, any other questions about Dart, about homework, about anything, any doubts, anything that you want to talk about? All right then, thank you. And we'll see you on Monday, and we will start with Flutter. We will create our first apps, and it will be fun. It will continue to be fun. So yes, we will also have something tangible and something that you can run on your device. Okay. Have a good evening, and I will send homework in during the couple of hours. I need to put it together into the Jira tasks, and I will also send you the recap of what we did today with some done tasks. I will also add you to my repository, so don't worry, you will have a lot of materials to study and check out for yourself. All right.